Welcome to this video series on understanding the RSA algorithm. We'll be starting with the basics, understanding what is encryption. We will also look at some history of encryption and lead into concepts behind RSA. So let me get into the full agenda of this video series. So as I said, we will start with the basics of encryption, look at the actors involved, the first party and the second party that needs to communicate with each other, a third malicious party, and what are the terminologies involved. We'll look at a basic example of encryption, and we will look at a few methods over in the past which continuously evolved over time. In the meantime, we will also see how encryption grew in complexity and how it made it harder for cryptanalysts. Cryptanalysts is the other word for code breakers, to break these encryption algorithms. And then we will look at modern encryption algorithms and how they are much more advanced than the ones in the past. And then we look at a very interesting problem with respect to all these encryption algorithms, be it the ones in the past or the modern ones, and that is the key distribution problem. And then we will move on to the solutions for the key distribution problem. There are two ways to solve this, one being the Diffie-Hellman key exchange method and the other one being the asymmetric encryption algorithms. And then we will look at the RSA algorithm, which is one example of an asymmetric encryption algorithm. Later on, we look at the elliptic curve algorithm, which is becoming more prevalent as of 2023. And then from a developer and programming perspective, we will look at some file formats that in which we store digital certificates and public keys and private keys. We will also look at other common cryptographic functions like hashing and signature, and how do we use these cryptographic functions, for what purposes. We'll look at that. And also another concept with respect to all this is forward secrecy. We'll touch upon that and end with some Java APIs that are commonly used for cryptographic purposes. Alright, let's get into the series from the next video.